absolute value is equal to 17. So what do we need to do first? Anybody?
Subtract 6 from both sides.
And why do we want to subtract 6 from both sides?
To isolate the absolute value.
Yeah, so we get the absolute value by itself. We're going to isolate it alone on the side. So the absolute value of 3 minus 2t is equal to 11. So now what do we need to do? We got the absolute value by itself. It's equal to 11. So that means the stuff in the absolute value could be what? Either equal to negative 11 or positive 11. And you don't have to write the or. I'm just writing it out because it kind of shows you the logic. And so then we just got to solve those two linear equations. So subtract 3 from both sides. Get negative 2c with negative what, 14? Divided by negative 2. So t would equal 7. That one. This one we subtract 3. Negative 2t is equal to 8. Divided by negative 2. And t will equal negative 4. So my solution set will be a set containing 7, negative 4. Any questions on that problem? No? Look at this next one. I have the absolute value of negative 4x is equal to absolute value of 20. What do we want to do first there? Anybody got an idea? Well, if you look at this absolute value, right, it does have a variable in it, but this one does not. So if you don't have a variable in absolute value, you can just evaluate that absolute value. And so this is just going to become the absolute value of negative 4x is equal to just 20. Would that matter? And so now that we have the absolute value isolated by itself on one side, equal to some constant, we're going to make this negative 4x is equal to 20, or negative 4x is equal to negative 20. And now we just got to divide both sides by negative 4. So x will equal negative 5 or positive 5. So that's going to be the elements in my solution set. Any questions on that problem? And the last one I gave y'all, yeah, this one's a little bit more difficult. So this one, we don't have the absolute value isolated, but the variable is an absolute value, so you can't just evaluate it. So there's a few different ways to think about this one. I think the easiest way is to think about, all right, what do we do when there's a fraction? We want to get rid of that fraction. What will we have to do to get rid of that 3 over 7? What would be the opposite of dividing by 7? Multiply both sides by 7. Right? And so we'll end up with 3 times the absolute value of x is equal to 7 times 1, which is 7. And then now we have a 3 times the absolute value of x. Let's divide both sides by 3. So we'll end up with the absolute value of x is equal to 7/3. 7 over 3. You could get rid of the fraction by multiplying by 7/3, which will get you there as well. But if you don't see that, that's fine. You take a step like that. And so now that we have the absolute value isolated by itself equal to a constant, and means that x could either equal 7/3 or x could equal negative 7/3. Oh, and that solves it right there, right? So our solution set would be the set containing 7/3 and negative 7/3. Any questions on that problem? Here. Home. All right. Let's see. And move them a little bit. I see. All right. So let's do the first one first, I guess. I really like that last one. So here we have the absolute value of x over 4 plus 2 over 5 is equal to 2. And notice the absolute value is already by itself. The opposite side is just a constant. And so we're going to make that step at the beginning. We're going to say x plus 4 plus 2 over 5 is equal to 2, or x over 4 plus 2 over 5 can equal negative 2. And once we're there, we end up with these two linear equations, but they have fractions in them. And what can we do to get rid of those fractions? It's got a denominator of 4 and 5. What's the LCM of 4 and 5? 20. So we're going to multiply both sides by 20. Let's just work on one for right now. We'll come back to the other one after. And so let's actually write it out. So we'll have x over 4 times 20 plus 2 over 5 times 20 is going to equal 2 times 20. And so if we work that out, what's going to happen? Well, just read. The 4 and the 20 will reduce. You're left with a 5 there. 5 and the 20 will reduce. You're left with a 4. There's nothing to reduce it on the right-hand side. So that's just going to be 2 times 20. So what we end up with is x times 5, which is 5x. 2 times 4, which is 8, is equal to 40. I like that. Any questions on doing that part? So it doesn't work out too beautifully or anything, but let's subtract 8 from both sides. So we'll have 5x is equal to 32. And we need to divide by 5. And 32 and 5 don't share anything in common. So that's just going to be our solution. X is equal to 32/5. Not too nice. Question on that part. Then we have to go back and do the other one, right? We're going to multiply both sides of this by 20. Now, the stuff on the left-hand side is the same as what we just did, so we should get the same thing there, the 5x plus 8. The only difference is the right-hand side, which was a negative 2, so that's going to be negative 20. Oh, sorry, negative 40. So we'll end up with 5x plus 8, get a negative 40. And you can work it out if you want to. I just need to do the same thing. And if we subtract 8 from both sides, we'll get 5x is equal to negative 48. And divide by 5, and it's not pretty either here. And so x is going to equal negative 48 over 5. Any questions on that? Questions here? All right, let's look at this one next. Wherever I put it. There it is. So yeah, the absolute value of u minus 5 is equal to negative 1/5. What do we need to do there? Anybody know? There's no solution. Why is it no solution? Yep. If you have the absolute value isolated and it's equal to a negative, there's nothing I can do. There's no value I can put in absolute value such that it would equal a negative number. Okay, remember it's either going to be 0 or positive. And so that's going to be no solution. Guess we can circle it. They'll probably have like a little, what do you call it, radial buttons, I think. No solution, no real solution. That's probably how it'll be on the homework. Just fill that in. Any questions on that one? And this one. So I look at this one and say, okay, the left-hand side got absolute value, right-hand side's got a negative. No solution, right? Why not? Anyone right now? Yeah, okay. So first off, the absolute value is just on the negative 9. And so that we can just evaluate. That's just going to be 9x is equal to negative 45. We can find a solution for that. We just divide by 9. And so it's just x is equal to negative 5. That's all there is to it. Okay. That one's kind of a trick one. Kind of trying to throw you off. Any questions on any of those?
So why? Like, if the other one was like equal to negative and now equal to negative,
What's the difference? All right, let me grab that other one. So if you look at both of these, right? Oh, can't overlay on that. But the difference is that the variable in this one is in the absolute value. And you have the absolute value by itself equal to a negative. There's nothing I can put in here. When I take the absolute value of whatever's in here, doesn't matter what it is, it's either going to be 0 or it's going to be a positive number. Do you see that?
no.
No? Hey, so like if I ask you the absolute value of, well, that's a bad example because we just did 9. The absolute value of 3, right? That's 3. Absolute value of negative 3, that's going to be 3. And absolute value of 0, it's going to be 0. So anything I put in here is either going to be a positive number or 0. Doesn't matter what it is, right? You put a negative number in it, it's going to give it its positive counterpart, right? If you put a 0 in it, you're going to get a 0.
Oh,
You see? So no matter what I put into this variable or this expression, when I take the absolute value, it's never going to be a negative value. When we look at this one, it's just a constant inside the absolute value. All right. So this we can just evaluate, which is going to be 9. The variable's outside of it. Yeah. The thing you want to be careful of, and let me see if I got a problem like that already before I do not. What the heck was that? Oh, okay. Forgot to put that one. The thing you want to be careful of is if you have, and I think we did one like this. Yeah, something like that. Right? So you look at it the same way. You got an absolute value, the variable's inside of it, and it's equal to a negative. But what do you think is the difference between this one and the other one we're looking at? Yeah, we need to get this absolute value by itself before we make any decisions. So we need to move that 3. And when we move that 3, it's going to be positive. And so now we can solve that one. So that one would have two solutions. Okay. Any other questions on that? In there. All right. Let's keep going. That is an interesting one. Yeah, let's do these. I was gonna skip the first one, but I kind of like it now. So try these 3. All right. Let's give them a try. So this first one, there's a few ways to go about this. Trying to think of what's the best way. We want to get the absolute value of 6x by itself, right? That's our goal. So I guess the most straightforward way is, well, let's subtract 5 from both sides. And we'll end up with negative absolute value of 6x is equal to negative 4. All right. And the absolute value is by itself on that side, but there's that negative there, right? And what we want to get is just the absolute value by itself. So what can we do to get rid of that negative? There's 2 ways we can do it. We can either divide by -1, or we can multiply by -1. So I like divide, usually what I do. And so we end up with, now is the absolute value of 6x. It's going to equal 4. So now this is one that we can work with. Got the absolute value of some algebraic expression is equal to a positive integer or a positive real number. Well, non-negative, really. And so we can say, well, 6x could equal 4, or 6x could equal -4. And so we just divide by 6 on both sides. Here we get x is equal to, that'd be 2/3 and -2/3. And so that would be your solution set there. The other way I was thinking about going is you could add the absolute value of 6x to both sides and then subtract the 1. And that'll get you to the same place here. Sides would just be swapped. And I was like, that's a little complicated. Any questions on that one? All right, this one, a little interesting. And the absolute value of x squared minus 49 is equal to 0. The absolute value is isolated, and it's equal to 0. So what does that mean? Does that have a solution? Is it like a viable thing? Can you take the absolute value of something and get 0? What do you think? Only 0, right? So we know that this stuff in our absolute value, the x squared minus 49, has to equal 0. There's no plus or minus. It just needs to equal 0. And then we take the absolute value of 0, we get 0. And so I've been doing the square root method a lot. So let's do the factoring method. It's the difference of 2 squares. So it could be x minus 7 times x plus 7 is equal to 0. 0 product rule, or 0 product property, not rule. X minus 7 is equal to 0, and x plus 7 is equal to 0. Add 7. You get x is equal to 7. Subtract 7. X is equal to -7. So my solution set is going to be 7 and -7. Any questions on that one? So it's equal to 0. Absolute value, you just equal to 0. I think we did one like that yesterday, actually. All right, now we're in some inequalities. So we got the absolute value of 5x less than 15. How are we going to set that up? If you struggle, and we'll do it for our first few. What that's saying is that 5x is less than 15 units away from 0. That's not very good. That means that it's in. If you go 15 units this way, or you go 15 units that way, that means it's between negative 15 and 15. And so to set up our inequality, it's going to be 5x is less than 15 and greater than negative 15. Okay. You know it can be done as a combined inequality if it's one interval. Any questions on setting that up? And then we'll just solve that. Divide each part by 5. We're dividing by positive, so the inequalities don't switch. And so we'll have negative 3 is less than x, which is less than positive 3. And so my solution set, my interval is going to be parenthesis, negative 3, comma, 3, parenthesis. Any questions on that one? If you struggle going from, or if you have any difficulty, I keep saying struggle, but I mean, you don't have to struggle a lot. If you just have to think hard about it, you can always do a number line to go from this to the interval notation. It really helps anytime you have problems with that. All right. And was that all 3 of them? Felt like it was fast. Okay. So what we got now? Oh, that is a good one. Got these 3. So everybody's dead. So let's talk about this first. So when we're looking at this one, and we picture it the same way we just did, we say, okay, well, this is 0, this is 8, and this is negative 8. Okay, well, it's saying that the absolute value of 2x is greater than 8. That means that it's jumping further than 8. So it's going past 8, landing somewhere over here. So what we're looking at is this area here. It's not equal to put a parenthesis. This area here, it's not equal to, so we put a parenthesis. So you can see it's two disjoint intervals. They're not together. So that means we don't want to make it a combined inequality. Here we want to write it as 2x can be greater than 8 or 2x can be less than negative 8. And so if we solve that up, I don't know why I'm dividing by 4. If you divide by 2, the answer is going to be x is less than negative 4. You divide by 2, and x is going to be greater than 4. Okay, so that's going to be our inequality. Any question on getting that part of that? All right, so what is that going to be in interval notation? That's the hard part. How we represent this one in interval notation? If it's less than negative 4, what's the lowest value it could be? Negative infinity up to negative 4. We put a parenthesis on that because it's not equal to it. And then we're going to union that. And how we're going to represent this one? Or to positive infinity. Good. That will be our solution. Any questions on that problem? All right, what's this next one? Layered. So here I have the absolute value of x minus 1 plus 3 is less than 6. What do I need to do there first? I want to subtract 3 because I want to get the absolute value by itself, and we'll get the absolute value of x minus 1 is less than 3. So is that going to be a combined inequality or two separate ones? What do y'all think? Yeah, we can always draw it out. So it's going to be based on 3 and negative 3. And it's saying x minus 1 is less than 3, so it's less than 3 units this way, less than 3 units that way. So it's going to be one interval, which means this can be a combined inequality. We have x minus 1 is less than 3, but it's greater than negative 3. It's got that upper and lower bound. And we just saw that add 1 to all the parts. And so we'll get negative 2 less than x, which is less than 4. And so our interval notation, negative 2 to 4. Any questions on that one? All right, this last one, this one's interesting. So it's an equation involving absolute value, and it's already set up. You have the absolute value by itself on the left-hand side, a positive real number on the right. So what we do is we say, well, x squared minus 3x could equal 4, or x squared minus 3x could equal negative 4. And so what we end up with is two quadratic equations. To solve those, you want to get one side equal to 0. So for this one, we'll subtract 4. And we'll get x squared minus 3x minus 4 is equal to 0. On the other one, we'd have to add 4, right? And so we end up with, for that one, is x squared minus 3x plus 4 is equal to 0. So two different quadratics. Got them set up. Ax squared plus bx plus c is equal to 0. Let's look at them. So this first one, the left one here, if we try to do that one with the AC method, AC is going to equal negative 4. B is going to equal negative 3. What multiplies to give me negative 4 adds to give me negative 3. If those are one off from each other, usually it's the number, the AC number and 1. So can I do it 4 and 1? Yeah, it looks like if I make the 4 negative, right? And so I'm going to write that. Oh, well, we know the A value is 1, so we know it's going to be x minus 4 times x plus 1 is equal to 0. And so that means that x minus 4 is equal to 0, or x plus 1 is equal to 0, which is going to result in the what x is equal to 4 or negative. So we got two solutions from that one. Questions on that one? So let's look at the other one. Here, if we do the AC method, let's see what happens. AC is going to be positive 4. B is still negative 3. What multiplies is going to be positive 4 and adds to give me negative 3. You only got a few options. You only got 4 and 1, 2 and 2, and they have to be the same sign. So you can do positive 2, positive 2. That won't give me negative 3. Negative 2, negative 2. That won't give me negative 3. Positive 4, positive 1. That won't give me negative 3. And negative 1, negative 4. That also won't give me negative 3. So Can't factor it. So what do you think we'll try next? Quadratic formula. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And I did put the quadratic formula on the ones that you need them on the test. If you need it for another problem, you should see it on the problems that you need it. So you can go get it from there. It's printed on the problem. So you can write it down and use it for it. Thought about adding it to all of them, and I was like, oh. Didn't seem like a good idea. So the first thing we're going to try is we're going to try to discriminate the b squared minus 4 ac. So we're going to do b squared, which would be negative 3 squared minus 4 times 1 times 4. Correct? Yep. Oh, that doesn't look good. So this is going to be 9 minus 16, which would be negative 7. Correct? Is that right?
Yes.
Yeah. Okay. Why? I was like, wait. So what does that tell us? What does the negative 7 tell us?
So we can't have negative.
Yep. So if your discriminant is negative, that means that part has no real solution. So the only solutions to our original equation, even so long ago, was 4 and negative 1. Oh, sorry about that. I will scroll back. So only the part that produced a positive 4 has a solution. The part that produces a negative 4 does not, because its discriminant is negative. Any questions on that? That was a difficult one. If you understand that one, I think you're a good place. What else? Was that all of them? Yep. Yep. Yeah, let's do these and then we'll call it. So they're all inequalities. So let's do that one first. All right. So let's see. So for that first one, notice that it is greater than 6. You got the absolute value already isolated. So if it's greater than 6, that means it's further away from 0, 6 units. I didn't draw that to scale very well, but. And so that means it's going to be past 6 over here, and it could be equal to it, so we'll put a bracket. But it could also be past negative 6 over there, so it's just like it's leaping past 6 units, or further than 6 units. So the way this is going to be set up is either 4x minus 9 is less than or equal to negative 6, or 4x minus 9 is greater than or equal to positive 6. Any questions on setting that up? So once we have that, then we just got to solve it. Add 9 to both sides here. And you get 4x is greater than or equal to 3. Move these out the way. And divide by 4. And you get x is less than or equal to 3/4. Then on the other one, we'll add 9 to both sides. We'll get 4x is greater than or equal to 15. And divide by 4. And so you get x is greater than or equal to 15 over 4. And so my interval notation, and just in case anyone's having trouble with it, you have 3/4 here, 15/4 here. it doesn't matter where I really write them. I just have to have them in the correct order. I know 3/4 is less than 15/4, right? And so we're saying what? It is less than or equal to 3/4. So that means it's going to be the left of it could be equal to it. It's greater than or equal to 15/4. So it's going to be to the right of it. It could be equal to it. And so my solution in interval notation is going to be negative infinity to 3/4 with a bracket on the 3/4 union bracket on the 15/4 to infinity. There you go. Any questions on that one? Nope. I think these are stacked. Yeah. Oops. No. All right, there we go. Oh. Sometimes this gets stuck. There we go. So this next one, we got the absolute value of 5x is less than -1. What do we need to do there? Well, think about it. We're saying that the distance is from 0 is less than -1. But how can we have a distance that's less than a negative? So we don't even need to graph it. All it is, oh, I forgot the word. No solution. You don't even need to worry about that. If you have the absolute value of some term with your variable is less than 0, which less than -1 is less than 0, there's going to be no solution. Because basically it's saying it's going to be negative. It's going to be less than -1. There's no way I can do that.
What if it was greater than a negative?
If it was greater than -1, what do you think it would be?
It would be 0 and all positive numbers, excluding the negative.
You're close. It could be anything. It could be negative infinity to positive infinity. Because no matter what I put inside the absolute value, it's always going to be greater than -1. It's either going to be 0 or positive, right? No matter what I have, whatever u is, it doesn't really matter. But that's always going to be greater than or equal to 0. So if you have some u is greater than -5 or something, that's going to be all reals all the time. So as long as it's this, it's going to be all reals. Any questions on that? All right. And this one's the one that set you up and tricked you from the last one. Notice that we have our side with the absolute value, and it's less than a negative. But you don't want to jump the gun and say, well, it's going to be no solution, because we need to add 9 to both sides first. So we end up with the absolute value of 1 minus 6x is less than 3. That is going to have a solution problem. I mean, I'll guarantee you it does. And if it's less than 3, basically that's what it's saying, that we got our 0, we got our 3, we got our -3. It's going to be upper and lower bound because it's traveling less than 3 units in either direction. So this is going to be 1 minus 6x is less than 3, and it's greater than -3. Ooh, what's going to happen there? That's fun. So any questions on setting that up? Nope. So we're going to subtract 1 from all our parts. And we're going to get, I'm going to come over. We're going to get -4 is less than -6, which is less than 2. Now to get the 6, no, to isolate the x, to get the x by itself, we need to divide by -6. Emphasis on the negative, because what's going to happen is our inequality relationships going to negate? It's going to flip it. And so what we're going to have is 2/3 is greater than x, which is greater than -1/3. And so when that happens, my advice and what I like to do is rewrite that from lowest to highest. The -1/3 is less than x, which is less than 2/3. It's a whole lot easier to understand than 2/3 is greater than x, which is greater than -1/3. Our brains don't, at least my brain, doesn't work that way. I always think left to right, increase. And so, if you want to write down interval notation, it's going to be open parenthesis -1/3 to 2/3 and close parenthesis. And interval notation always needs to be increasing or decreasing. So that's why it's a pretty big recommendation to switch that up. If the signs do switch, it's a good idea to rewrite it the other way. That way you don't get confused. Any questions on any of the problems or anything?